Hello students, how are you? So today we are going to start the chapter structure of atom. So what we have to focus on the word atom. In the previous chapter we have read about atoms and molecules. So I know that you have all been curious about what is an atom, how has been formed, yeah, what about the theory of the atoms or what atom constitutes. So in the ancient times it was believed that atoms are smallest particle. Atoms are smallest particle. You know what does it mean? That smallest particle is that nothing is much smaller than atom. Nothing is more smaller than atom. So this theory was given by Dalton. So what Dalton said that atoms are indivisible. Atoms are indivisible. So this word itself, the word atom itself came from word atomio, which means indivisible, or it was also mean uncuttable. Uncuttable. I know this sounds weird. Uncuttable. Yes, but this word is correct. Uncuttable, which cannot be cut or which cannot be further subdivided. Understood? So this Dalton's atomic theory consists the main sentence was that atoms cannot be further subdivided into smaller particles. So this theory was completely wrong. So this theory itself said that atoms are indivisible, but what we are going to study more about that atoms can be subdivided further also, and atom can be subdivided into mm, subatomic particles. Atom can be subdivided into subatomic particles, which includes electrons, protons, and neutrons. So I know that you guys might be curious about how they find it out. How they find it out that electrons were present, how they find it out that protons were present, how they find it out that neutrons are present. You might be very much curious that it was an accident. Discovery of electron was itself an very much an accident, and this accident was done by not only one scientist. And here comes an experiment which is known as cathode ray experiment. Cathode ray experiment. Cathode ray experiment. So this theory was came into the effect by J.J. Thomson. You might know very well about J.J. Thomson. J.J. Thomson was the scientist who discovered electrons. So J.J. Thomson conducted an experiment that known as cathode ray experiment, in which he passed high voltage current through an cathode ray tube. So let's first talk about an experiment. This experiment includes a cathode tube like this, and here this cathode ray was connected towards the vacuum, or we could say that there was a pump which was extracting the air from the cathode tube. Okay, so they can maintain a very low pressure. And here an electric current was passing, which was nearly about more than 11,000 volts. It was more than 11,000 volts. It was the very high current which was passing through the cathode ray tube. So this is negative, this is positive, and this was supposed to be negative and positive side. Okay, so here they took the gas. Inside the cathode tube. Gas was present. Okay, and when current was passed through this, there was a light coming out from the cathode tube. And that light mentioned about was very much bright, and it was dark in color. It was little bit dark in color, and it was supposed to be not present there because nothing was inside the cathode ray tube, and it was connected to the vacuum, and hence there was a very low pressure inside the cathode tube, and nothing was in between, between the two electrodes. Understood? So this experiment told us about that something was present between these cathode tubes, and that just made J.J. Thomson very much curious about what might be present inside the cathode ray tubes. So when he just conduct this experiment, cathode ray experiment, and discharge ray, and he conduct more experiments. Like very first, he just observed that all the cathode ray tubes were inside the was in the straight line, was in the straight line. And here, and you might be get little bit curious that how this could happen, but yes, this could be possible when cathode ray was passing, when cathode rays were passing through it. He placed something fan like structure, some fan like structure inside the cathode ray tube, like this fan like structure. It was connected here, something was there which can be rotated, which can be rotated. Okay, so this experiment made this fan move. This made the fan move, or we can say it started rotating. This fan started rotating. So very much very first, the fan put inside by J.J. Thomson was started rotating, was started rotating. So what does this implies? Anything anything if suppose you are holding a fan, if it starts rotating, what you are going to understood from this, what you are going to infer from that, that you are going to, there something is pushing the fan, that's why fan starts rotating. Okay, there is no other chance that fan will start rotating until and unless something would not going to push the fans. Okay, so what he concluded from this, he concluded that the fan starts rotating due to something present inside the tube, present inside the tube, consists some mass, this is very much important. So what he inferred, that something which is present inside the tube was consists some mass. Okay, so this was not at all supposed to be believed that there is even atoms consist of mass, even atom does consist some mass. So this cannot prove that there is some subatomic particle also. Yes, obviously this could be, this some mass could be an atom now, this some mass could be an atom. So what was the second experiment he did in this cathode ray tube? So he put not just fan, what he did, he put two charged electric plates. He put electric plates around the cathode ray tube. He put electric plates around the cathode ray tube. So what happened? Just listen to it. Just listen to this. What happened? That when the cathode ray tube were moving in the straight line, when cathode ray tube was moving in the straight line, these cathode ray tube, these cathode rays got deflected. These cathode rays got deflected. So this was very much interesting. How when these cathode ray, suppose this is positive and this is negative. So when these cathode rays were deflected towards the positively charged plates, so from this point, J.J. Thomson inferred that these cathode rays are negatively charged particles. Negatively charged particles. And this was the, you could say that this was the something which was very much important, which was inferred from this experiment. This was the very much important finding, that these cathode rays were the negatively charged particles. And why this was very much important? Because according to theories, or according to the existence, it was supposed to be atoms were supposed to be neutral. Atoms were supposed to be neutral. How you can say that atoms were supposed to be neutral? Just understand this. If atoms were not supposed to be neutral, then how we could exist? How even this earth could exist? how this sun could exist or how this even universe could exist. If something is not neutral, if something is not neutral, how they can exist? No, they can't exist until and unless they are not neutral. And if they are charged particles, it means that something else was present there, something else was present there. And before this experiment, it was truly known that atoms are present. It was truly known that atoms are present and it cannot be further subdivided. From this experiment and from this particular experiment, when he put the two charged plates, one positively charged plate and second is negatively charged plate, around the cathode ray tube, it was so clear that these particles are negatively charged. It means these particles were coming out from an atom. These particles were coming out from an atom. It means there are some other particles were also present, and these negatively charged particle consist some mass, and these charged particle consist some mass. And if negatively charged particles consist some mass, it means they are particle in nature. From these 2 points, it was clear that something which was present inside the cathode ray tube have particle nature, have particle nature. And this was the breakthrough, and this was the breakthrough which discovered electron. And J.J. Thomson named it as an electron. This J.J. Thomson named it as electron. So there was, and theory came from J.J. Thomson, which we also call J.J. Thomson model of atom. J.J. Thomson model of atom. And what does this model say? A plum pudding model. It is also known as plum pudding model, in which he said, if there is something which is round in shape, if there is a plum which is round in shape, and electrons are embedded just like choco chips are embedded in that pudding. Choco chips are embedded in that pudding. Or we could also say that watermelon structure, that all these parts are fruit part which we eat, and these blue parts are the seeds. These blue parts are the seeds. And if you know about the watermelon, that the red part are the positively charged part, and the seeds are the electrons, and the seeds are the electron. This plum pudding model, or we can also say that watermelon model, that made a huge discovery where it was J.J. Thomson mentioned that electrons are embedded in the electrons are embedded in the positively charged something space, or we can say that yes, positively charged space. Or we can also say that the positively charged particles or positive charge is uniformly distributed all over the area, and electrons are embedded inside it. Okay, in simple words, and it is somewhat distributed in a way where the electrostatic charge are equal, where it is forming a stable electrostatic charge. And you already know what I have said, that it was an atom was supposed to be neutral, completely neutral. Hence this theory was given. And this theory was completely wrong theory. J.J. Thomson just provided this model on the basis of finding of electrons. He didn't knew about protons, he didn't discover the protons, he didn't even know about the neutrons and nothing. He just put a model where he find out the electrons, and he proposed that there is a model where the positively charged or positive charge is uniformly distributed all over the area in which electrons are embedded in it. So this theory was completely wrong, which it cannot be possible at all. This cannot be possible at all, because positive and negatively charged will clash with each other, and hence an atom will destroy at any cost. So after that, there was a model which is known as Rutherford's model. Rutherford's model came into effect. But Rutherford's model knew Rutherford's model knew that there are positively charged particles. Rutherford's model knew that there are positively charged particles. So before moving to Rutherford's model, we have to study about the discovery of protons. We have to study about the discovery of protons. So protons were discovered in the same way in which cathode ray experiment were done. So this experiment was also known as anode ray experiment. Anode ray experiment. Same setup was done. Same setup was done. No difference in the setup. Everything was same. Same 11,000 volt was present there. Same 11,000 volt was present there. And what happened there? What happened in this part was very much interesting. Here, hydrogen gas was taken. Here, hydrogen gas was taken. H2 gas, hydrogen. What we know about hydrogen? Its atomic number is 1. What we know about hydrogen? Its atomic number is 1. Only one electron is present and one proton is present. Only one proton is present. So when this experiment was done, it was seen that it was discovered, protons were discovered by Goldstein. The scientist was Goldstein. So after the J.J. Thomson's model, and after the cathode ray experiment, many scientists were started doing this experiment, the same cathode ray experiment, by taking different gases, and changing some criterias, like here in the cathode ray tube, here zinc sulfide was applied. Which was started glowing when cathode ray. In the previous experiment, here zinc sulfide was taken when cathode ray was passed through these. When cathode rays were passed through these positively charged electrode and it hit the backside of the cathode ray tube, this backside was started glowing. Or we can also say that here zinc sulfide screen was used. And this zinc sulfide started glowing. But Goldstein didn't apply the zinc sulfide only at this point. He also applied the zinc sulfide at this point, and he took and this electrode was taken like perforated. It was perforated. Perforated means like it was having some holes. Here again it was connected to vacuum. And when highly charged particles pass through the cathode ray, it was supposed to move forward. Just like cathode rays. It was supposed to be move forward. But no, not this happened. It was something different what he observed. He observed that some of rays was coming backward. And in this experiment, he took many gases, but this experiment was successful only with hydrogen. And when he put again the same method, what electric plates were applied here. Take it positive and this as negative. Okay, so when positive plates were present, these anode rays, these were known as anode rays. These were known as anode rays. These anode rays started getting deflected downward. What he understood from this experiment? These were positively charged species. And this experiment was done. A fan was put inside, and the fan starts rotating, due to something present inside the tube. which consists some mass. Same fan was put inside Goldstein's experiment also, and what he inferred from this, that this was carrying some mass. This was carrying some mass, and this was the discovery of proton. This was the discovery of proton. And we have concluded that how discovery of electron took place and how discovery of protons took place. You might be curious again about the discovery of neutrons. Neutrons were discovered around in 1930s. Around in 1930s, even after the successful experiment from Rutherford and Niels Bohr's atomic theory, which is widely accepted, and still we are studying about Niels Bohr's model. In 1930s, Niels Bohr's model came into the effect in 1914. And after some 15 or 16 years, neutrons were discovered, which again speculated a new version or new theory of the atoms, about the atoms, structure of atoms, what consists, how protons are present there, how electrons are present. And this was explained by Rutherford, how electrons are present inside an atom, how protons are present inside an atom. So in the next lecture, we're just going to study about the Rutherford's experiment, how he did this experiment, and how he just mentioned about the position of electrons, position of proton, and everything about the atom. After that, Rutherford's experiment, it was Niels Bohr who completed his theory or completed this model, where we got to know everything about an atom, how electron move, how proton stays inside the atom. There were many things which was explained by Niels Bohr. And even after Niels Bohr, there was again an atom which is known as quantum theory of atom, which is the only theory right now present about the atom. And we are only going to study about the quantum theory of atom in class 11th. So we'll first going to study about Rutherford's experiment and Niels Bohr's experiment or Niels Bohr's theory of an atom. Thank you so much. So take care. Bye bye.